Hi everyone, today I want to show you how to calculate one sample t-test in R. The one sample t-test is a statistical hypothesis test used to determine whether an unknown population mean is different from a specific value. I can use the test for continuous data, and data should be a random sample from a normal population. If it is not normal and I look at the sample size of the data, if it is small, I might not be able to test for normality. I might need to rely on my understanding of the data. However, if I cannot safely assume normality, I can parametric test without normality assumption. I need one variable, I need testable hypothesis, I need a mean of population which must have a value to test against. The assumptions are independent, that is, it must be unrelated value to one another. Number 2, a continuous variable. Number 3, values obtained via a simple random sample from the population. The population is assumed to be normally distributed. Let's take a look at this example. This is an example under one sample t-test. These are the measurements taken. Now the first step to do is to use hypothesis testing, which the mu equals to 20 and the mu not equals to 20. Now let me quickly show you how I calculate this without R. So our n equals to 31, then the x bar, which is the mean, is equals to 21.39. The alpha given to us is 0.05, that is 5% confidence level. And I want to show the variance for the data, and the variance for the data is calculated from that formula, which gives me 2.53 as the answer. Then the degree of freedom, I can get it from the number of samples, which is 31 minus 1 give us 30. Then I can find the T critical. T critical is gotten from the table, the T distribution table, which is calculated to be 30 under 0.025. Then it gives me 2.0423 when checked from the T table. Also, I want to quickly show you how I get my T calculated, that is the T test statistics. It is calculated with this formula, which is the mean minus the mu over the variance of the mean, where the variance of the mean is calculated as b, the variance over the root of n, the square root of n, which gives me 0.46. Now by calculating the T critical, it gives me 1.40 over 0.46, which is 3.07. Now this is the T calculated and the T critical, which is gotten from the table, and we can make a conclusion from here to show that the T table and it is do this in R. In the R Studio, I have my data. Use this very code to read my data into the table, and I attached the data, and this is the values. Data, and I want to do a small data visualization from the Then I use box plots. The next thing for me is to just quickly show a simple assumption where the sample size are drawn from a population with a normal distribution. So I use QQ normality to do that, which give me these beautiful graphs to show the normality tests for that. Then I can also use QQ line to draw a straight line on that. The next thing for me to do is just to calculate one sample t-test. So I will run the code to calculate for me where I make the mu to be equals to 20, because that's what we are testing against. And when I run the code, I get this. You can see the value for my t calculated, which is 3.08, which is the same thing as what we calculated before. Then the degree of freedom is given us to be 30, the p-value to be significant. Then we can see the alternative hypothesis to be true, mean is not equals to 20. Now we can make our conclusion from this now.